In practice problem 10.2, determine the phasor currents I1 and I2 in the circuit. For coil 1, negative 12 bar angle 60 degrees plus quantity 5 plus J2 I1 minus J3 I2 equals 0. Since our current are both entering the dot, our N J3 will be negative. Our equation 1 will arrive at 5 plus J2 I1 minus J3 I2 equals 12 bar angle 60 degrees. For coil 2, negative J3 I1 plus quantity J6 minus J4 I2 equals 0. We will transpose negative J3 I1 to the outside of the equal sign, and J6 minus J4 I2 is now equal to J3 I1. To get the value of I2 for our equation 2, we will divide J3 over J6 minus J4, which is J2. J3 over J2 is equals to 3 over 2. Our I2 is now equal to 3 over 2 I1, or equation 2. Now substitute equation 2 to equation 1. 5 plus J2 I1 minus J3, 3 over 2 I1 equals 12 bar angle 60 degrees. 5 plus J2 minus J4.5 I1 equals 12 bar angle 60 degrees. 5 minus J2.5 I1 equals 12 bar angle 60 degrees. Then I1 equals 12 bar angle 60 degrees over 5 minus J2.5. Our I1 will arrive at 2.1466 bar angle 86.5651 ampere. Now, we will substitute I1 to equation 2 to get our I2. 3 over 2 times 2.1466 bar angle 86.5651 degrees is equals to 3.2199 bar angle 86.5651 degrees ampere for the value of I2. For practice problem 10.5, for the linear transformer, find the pi equivalent network. We have the given M equals 2 Henry, L sub 1 equals 10 Henry, L sub 2 equals 4 Henry. To get the pi equivalent network, we will use the pattern for its equivalent network. We have to find the L sub A, L sub C, and L sub B. For L sub A, we have the formula L sub 1 times L sub 2 minus M squared all over L sub 2 minus M. We have 10 times 4 minus 2 squared all over 4 minus 2. It is equals to 36 over 2, and our L sub A will be equal to 18 Henry. For L sub B, we have the formula L sub 1 times L sub 2 minus M squared all over L sub 1 minus M. We have 10 times 4 minus 2 squared all over 10 minus 2. It is equals to 36 over 8. L sub B is now equals to 4.5 Henry. And for the L sub C, we have the formula L sub 1 times L sub 2 minus M squared all over M. We have 10 times 4 minus 2 squared all over 2. It is equals to 36 over 2, or our L sub C is now equal to 18 Henry. After we get the values, we will substitute it to its respective places to get the pi equivalent network. Our L sub A is 18 Henry, L sub C is 18 Henry, and L sub B is 4.5 Henry. For practice problem 10.6, calculate the phasor currents I1 and I2 in the circuit using the T equivalent model for the magnetically coupled coils. For this problem, we will convert the given circuit to its T equivalent network. We have the pattern here for the T equivalent network, which have the value of L sub A, L sub B, and L sub C. To get those values, we have the formula for L sub A equals L sub 1 minus negative M. Since our currents, since I1 is entering the dot and I2 is leaving the dot, our M will be negative. L sub 1 minus negative M is equals to 5 plus 3. L sub A is now equal to 8 Henry. For L sub B equals L sub 2 minus negative M, it is equals to 6 plus 3, or our LB, or our L sub B is equal to 9 Henry. For L sub C, it is equals to negative M. L sub C is now equal to negative 3 Henry. Now we will redraw the main circuit and convert the coils into the equivalent model. We have for L sub A is equals to J8 ohms, L sub C negative J3 ohms, and L sub B J9 ohms. We will use the new circuit diagram in finding I1 and I2. Using mesh analysis, at mesh I1, we have negative 12 bar angle 0 degrees plus quantity negative J4 plus J8 I1 plus negative J3 times quantity I1 minus I2 equals 0. Negative 12 bar angle 0 degrees will be transposed to the other side of the equal sign. The equation will become negative J4 plus J8 I1 minus J3 I1 plus J3 I2 equals 12 bar angle 0 degrees. Since negative J4 plus J8 is equals to J4, we will combine like terms to negative J3 I1. J4 minus J3 I1 plus J3 I2 equals 12 bar angle 0 degrees. J4 minus J3 is equals to J. J4 minus J3 I1 is now equal to J I1 plus the J3 I2 equals 12 bar angle 0 degrees. That is for our equation 1. For mesh I2, we have negative J3 times quantity I2 minus I1 plus quantity J9 plus 12 I2 equals 0. We will distribute negative J3 to I2 and negative I1. We will distribute I2 to J9 and positive 12. Negative J3 I2 plus J3 I1 plus J9 I2 plus 12 I2 equals 0. We will combine like terms like negative J3 I2 plus J9 I2, and it will become J6 I2 plus J3 I1 plus 12 I2 equals 0. We will transpose the positive J3 I1 to the other side of the equal sign and will become negative J3 I1. Since J6 and 12 are like terms, we can say that quantity 12 plus J6 I2 is equals to negative J3 I1. To get the value of I1, we will divide quantity 12 plus J6 I2 divide by negative J3. To simplify the equation, we will get the negative 2 plus J4 I2. In polar form, I1 is now equal to 4.4721 bar angle 116.5651 degrees I2. That is for our equation 2. Now we will substitute equation 2 to equation 1. We have equation 2 equals I1 equals quantity 4.4721 bar angle 116.5651 degrees I2. And equation 1 equals Ji1 plus J3I2 equals 12 bar angle 0 degrees. The equation will become J quantity 4.4721 bar angle 116.5651 degrees I2 plus J3 I2 equals 12 bar angle 0 degrees. Multiplying J to the value of I1 will arrive at 4.4721 bar angle negative 153.4349 degrees I2 plus J3 I2 equals 12 bar angle 0 degrees. Simplifying again, 4.1231 bar angle 165.9635 degrees I2 is equals to 12 bar angle 0 degrees. To get I2, we will divide 12 bar angle 0 degrees to 4.1231 bar angle 165.9635 degrees. And we will get 2.9104 bar angle negative 165.9635 degrees ampere for the value of I2. Next, we will substitute the value of I2 to equation 2. We have the equation 2 equals I1 equals quantity 4.4721 bar angle 116.5651 degrees times 2.9104 bar angle 165.9635 degrees. Simplifying, we get the value of I1 equals 13.0156 bar angle negative 49.3984 degrees ampere. In practice problem 10.11, in the autotransformer circuit in figure below, find currents I1, I2, and I0. Take V1 equals 1250 volts, V2 equals 800 volts. We have the given V1 equals 1250 volts, V2 equals 800 volts, and our load is equals to 16 kilovolt amperes. As we can see, we can get the value of I2 by using the value of the load and the given V2. We can say that I2 equals 16 kilovolt ampere over 800 volts. We can cancel the V sign to get the unit ampere. 16 kilovolt amperes over 800 volts equals 20 ampere for the value of I2. We know the idea of KCL, that current flowing in equals current flowing out. Thus, I1 plus I0 equals I2. This formula will be useful in finding current I0 after we find the value of current I2. For now, we will treat 16 kVA as our power out or P out. There is a theorem that says power in or P in is equals to P out. Thus, V1 times I1 equals 16 kilovolt amperes. We will equate the formula and becomes I1 equals 16 kilovolt amperes over V1. 16 kilovolt amperes over 1250 volts equals 12.8 ampere for the value of I1. Lastly, to get the value of I0, we will equate this formula. The formula for I0 will become I0 equals I2 minus I1, or 20 minus 12.8 amperes equals 7.2 amperes for the value of I0.